is vectors in 2 dimensions, which means we're probably going to have 3 dimensions at some point in time. Yay! All right, who can tell me what a vector is in their own words?
A line, right?
A line, kind of.
Forever a single word. Or is that?
Vector doesn't do that, but you're on the right track. Starts as an initial point. Has a terminal point. If it has a terminal point, then what's the purpose of the arrow at the end of it? Yeah, it tells you that's the direction. Meaning, you started here and you went this direction to get to that point. That's the point of the arrow. Okay. Anything else about vectors that we know? Nothing? Didn't learn anything else? Okay. Now let's see if I can add to your frustration. Let's just talk about some examples here. Example 1. This is not number 1 in your book. I'm just making these up. If I have the vector u and we say that's 2, 4. These are the symbols we use to say that it's a vector. It is not a coordinate. Okay? So it is how you get from the initial point to the terminal point. So it is a guide. It's like slope. The x value here, the first value here, is your horizontal movement. And the y value is your vertical movement. So unless I give you an initial starting point, you're going to assume you started at the origin, okay? Now, instead of x and y, we're going to use I and j. And that lets us know that we're dealing with vectors as far as you're concerned right now. So if we're starting at the origin, I go to the right 2, and I go up 4. And that would be the vector u.
So it's in the
Origin?
yeah. Why?
Unless I, what?
Why is it in the origin?
Unless I give you a starting point and a different initial point, it's always going to start at 0, 0.
Okay, I didn't see the point where your arrow was.
Oh, okay.
I didn't
So let's say I give you the initial point of, this will be example 2, initial point of -5, 4. And I give you the vector v to be 3, -2. I want to know what the terminal point is. So you don't have to graph it to know how to do this, but here's the visual behind it. Here's our initial point at -5, 4. That's where we're starting. That's just a point. That's not an arrow or ray or anything. That's just a point. Notice the difference in the symbols. And then that's where I'm starting, and I'm going to move in that vector direction. Meaning I'm going to go to the right 3. 1, 2, 3. And I'm going to go down 2. 1, 2. And that is where the arrow ends up. And that's that vector, v. So the vector doesn't always have to have an initial point at 0, 0. Okay. So that's a type of problem you got to do. Given an initial point in a vector, where did you end up with? All you really had to do was add 3 to your x, add -2 to your y, and you ended up, that'll give you your endpoint, which you would write like this. That's your endpoint. Don't use your greater than or less than symbols for points. All right. Now let's talk about.
Is that the terminal point?
Yeah, this would be the terminal point. Now we're going to talk about multiplying and adding and subtracting. It's the same type of thing with everything else we've done. The same properties, community property addition is the same in vectors. 2 plus 3 is the same as 3 plus 2. So vector u plus vector v is the same as vector v plus vector u. Those properties are in your book. I wouldn't put those on my reference sheet, but if you need to put them on your reference sheet, then do so. Same thing with matrices if we have scalars. So in this case, if I say, let's let vector u equal -2, 5, and I want to know what 2u is. Scalars are the same thing as in matrices. If you have a scalar in a matrix, you just multiply all the entries in your matrix by that number. Same thing with vectors. So you're just going to take 2 times each of those values. So 2 times -2 is -4, 2 times 5 is 10. So visually, what does that do? -2, 5 is right here. There's your vector u. If I multiply it by 2, I'm at -4, 10. What did it do? It just doubled the length. That's all. Minus u. What's the coefficient on minus u? -1, so that's a scalar. So what's that going to do to the vector? -5. What happened? Kind of like your polar coordinates with a negative radius. What's a negative radius do? Opposite direction. So I'm going to try to tie all this together real quickly. In rectangular form, you have x and y. Complex form, you have a and b, I. When we're trying to find the length of the radius, your modulus, that was r equals your a squared plus your b squared, right? Which gave you the length of the radius. Don't these kind of look like radii? So in this case, when I write something like that, that's asking for the magnitude, the length of your vector. And you find it the exact same way. In this case, it's going to be these values. You can say it's x and y if you want. But how we write this in expression form, and this is something else you know, is you would write this like this. 2i plus -5j or minus 5j. And it's these coefficients or these values that you put in here to find the length, because this is just how far you're moving left or right. This is how far you're moving up and down. And isn't that the Pythagorean theorem? Distance formula? Distance formula equals the square root of x sub 2 minus x sub 1. Isn't that how far you're moving left and right? Yes or no?
Yes.
That difference is the change horizontally. And then you have the change vertically there. Well, that's what your vectors are. This is the first number in your vector. That's the second number in your vector. So you're going to find it. You find the magnitude the exact same way we've been doing all the other stuff. That's not changed. We're just using vectors instead of rectangular coordinates. Good so far? All right, let's find out if you really understand what I just said. Given 2 vectors, I'm going to ask you to do a few calculations. Let's see here. Let's just make this up. We're going to make this up. Example 4.
Yeah.
Questions?
No.
Okay. So vector u, we're going to say, give me 2 numbers.
2 and 3.
2 and 3, good. Vector v,
5 and 2.
all right, good. All right, everybody. We haven't really talked about this. A u plus v, I'll go ahead and talk about it now, and then I'll have you do something else. U plus v just means this. You're adding both of the x values together, and you add both the y values together. So this is going to be 2 plus 5. This will be 3 plus 2.
3 plus 3.
All right, and so what we get is another vector, 7, 5. Now I wanted to give you the visual of that. What did we do? All we did was we add the same positions together. If we subtract those positions. Visually, this was in your book. Those of you who did it should understand what this forms. So here we have 2, 3. That is u, and 5, 2. Them added together is, those added together is 7, 5. What does that look like? Huh? Parallelogram. Okay. So,
two. It's not just me, I just spoke up.
that's fine. That's fine. So parallelogram, that's kind of your book, and that's not important that what shape it makes. It's just telling you when you add the two vectors together, that's really how you can visualize what it's gonna where it's gonna end up before you actually do it. Okay. Now tell me this. I want the magnitude of u. So do what I was saying down there. The magnitude of u. Mm-hmm. U. So we're combining a bunch of examples in one. And then find the magnitude of v. You got that right. Awesome. Simple? Alright, this one? V. Did you not get it? Did you not get it?
Hold on, moving.
Did I do that right?
Lockwood. It's
Oh, no.
two.
Two. On the
Down.
bottom.
5 plus 2.
Oh, sorry. I was thinking ahead.
I was
Thanks.
yelling. I was helping. That was yelling.
Be compassionate.
Yeah, exactly. I'm thinking
25 and-
Lockwood.
Okay, so this is right. 25 and 4 is 29. Who got that? Thank you. Good. Alright, now you ready for a complex one?
Wait, so what's the actual answer? What would you say?
The magnitude of u is the square root of 13. The magnitude of v is the square root of 29. These are distances from the initial point to the terminal point. That's what you just found. Okay? Now do this one. This is going to be hard. 2u minus 3v, and I want the magnitude of that. So these are like grouping symbols. You got to do what's inside first. Do multiplication before subtraction. What'd you get?
Oh, that's close.
Wait a second.
You don't keep the negative sign on the 3? That's what I did.
Right here?
Yeah.
Well, just remember you're doing it. You don't do the subtraction until you do this multiplication. Okay? If you're going to do that, then you change this to addition. Did you change this to addition? Yeah, you can't make that negative unless you're going to make this addition. Okay? Why isn't this negative 11? What?
Where is it?
Well, isn't the square root of negative 11 squared?
Because you do negative 1 squared.
God, I'm looking for a different answer. Those are great answers. What are we finding?
You can't have a negative. This isn't.
Thank you. That's what I wanted to hear. Okay. It really comes down to what you're finding. So, well, don't, when you take a square root, don't you get a positive and a negative anyway?
Yes.
Okay, so you need to be thinking about what it is you're finding. Alright, so that was complex. Let's go back and do something simple again. Example 5. P is at 1, negative 3. Q is at 4, 5. I want the vector that this makes. I want the vector that it makes. How would I figure that out? That's the best explanation. How do you know what the initial point is?
Because it has a
What's your first point?
1.
P.
1.
P is the initial point. They don't say that in the book. They just give you 2 coordinates. You just use the first coordinate as your first point. Okay? So I want that vector. So really, this is what it's asking. So this 1 minus 3. Your slope formula basically is how you figure it out. So that's 3. This is 8. Think about it. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. We got that right? Okay, good. You guys are so smart.
Thank you.
Gosh, I don't know what to do.
Really, really nice.
Okay, now I want you to write this. Just to make sure you caught on to this, I did this a minute ago. Write your vector in terms of I and j. So, actually write this vector in terms of I and j. So you found the vector, now write it in terms of I and j. How do we do that? It's an expression. I plus j.
3i plus 8j.
3i plus 8j. Eventually we want to be using these expressions to do some calculations. So this is why we write it like this. Just put I and j next to them. Okay? What if I said this? What if I said graph negative 2i minus 4j? Graph that. Tell me where to graph it. No.
Negative 2, negative 4.
Yep. You got that right.
I did.
Did you forget your vector? Or did you just put a point?
If they don't
No, I
give you
didn't.
an initial point, you shoot from the argument.
Yes.
That's what we said, like, we're going places.
I'm just.
20 minutes ago.
She's just making sure. You guys need some compassion.
It's not me, it's Corey.
You were the one who said it.
Okay, graph that please.
Wait, what did I say?
5j, graph it. Gabby, where do I graph that?
On the J.
Yeah.
Right?
Yes. Okay. Because this is really 0i plus 5j. Okay, last one. Where do I graph that? Yeah. And what is the vector? What is this vector? If I asked you to put it in vector form, what is it?
2,
2, 0. Thank you. You guys are brilliant. Amazing. Unfortunately,
some compassion. Stop. I won the day. 47.
unfortunately,
I don't know how to
nobody's groaning yet.
Wait, what do you mean, unfortunately?
Everybody think it's easy so far?
I'm 70.
Can we not use I and J? They look really similar.
Nope. You have to use IJ.
I've been on my
I'm
phone.
gonna get it back.
You lied. I know.
horizontal component. This is probably something you put in your reference sheet. Who can tell me what the horizontal component is?
12. No, it's not 12 block, but I promise.
It's how far you're moving. So A, I'm gonna say A. That's kind of what we've already used. A is the magnitude of the vector times the cosine of theta. So basically the distance of your vector and the x value that you get when you have the degree. Cosine is your x value. So simpler, just in simple terms of how you understand it. And then you have the vertical component. What do you think that's going to be?
Sine theta.
The distance of the same vector times sine theta. Good job.
Thank you.
So that's important because you're not always going to be given all the pieces that you would like. Sometimes you have to work them a different way. So that's what this is about. This is number 42 in your book. I want to find the horizontal and vertical components with the given length. So the given length of the vector is 50. And the direction, so the theta is 120 degrees. So this is what you're doing. The horizontal component is the length of the vector times the cosine of the degree. I'll wait for you to catch up.
So you mark that for 120.
Well, it's that same thing. I was just putting in there. Don't, what?
Does it matter which one?
No. Because I'm going to ask you what is the x value at that degree. What is the x value at that degree? At 2 pi over 3. What is it?
Negative
1/2. 25.
I'm disappointed.
It just says a negative 25.
So that's your horizontal component. Vertical component. What is the y value at 120 degrees? So you get 25 radical 3. So this is, now I want it written with I and j. So negative 25 I plus 25 radical 3 j. Write your I and j correctly.
Which one?
Which one's I and j?
Don't know.
So do,
Do the hooks.
if you don't do a hook, then I'm assuming it's an I.
That's
Okay?
not what I was asking.
But make sure the hook is at least on the j going the correct direction.
Yes, they do.
Don't put a hook on the first one then.
Yeah.
And that way I know which one you're talking about. Or do a capital J, but I'd rather do lowercase if you can.
I'm gonna do them both capital letters.
Okay. Remember, capital letters mean something different in math, but for this assignment, I'll put that again. Alright. Okay, number 50, this is the last example. If the vector is at 49, I want to know the magnitude, and then I want to know the angle that it makes. So first, everybody find the magnitude. I'm going to draw it for you so you get a visual. Perfect straight line. Magnitude, please. Yes. So you didn't get to get rid of your trig stuff, did you? Still have to have a little trig there. Should be done. What is it? Yeah, 41. 1681 square root is 41. Yay.
Yeah, you got it.
Okay. All you smart people. How many degrees is that? Oh, trigonometry.
What's the question?
How many degrees does that make?
17 degrees. It's a
Don't
guess.
guess.
It's a guesstimation.
What?
It's a guesstimation.
That's a pretty good guess.
It's pretty close.
It's close.
16.
How do I figure it out? You guys act like you've never seen a right triangle before. Okay, now let me explain something here. Tangent theta. What do we know tangent theta to be?
Y over
Y over x. What did we do last chapter? We put the b over the a. What do you think you're going to do here? The j value over the I value, which is 9 over 40. So what we have here is the tangent of theta equals 9 over 40, and that's correct because this right triangle here, this is 9, and this is 40, y over x. Okay, now how do I figure this out? I've been doing this for a couple chapters. Inverse, yeah. So the inverse of 9/40 is what on your handy dandy calculator in degree mode, please? Oops.
5
4.68 degrees. 17 would have not gotten you any credit, but it would have been a good guess.
Austin, you were close, man.
Any questions? Okay.